Good morning. My name is Andre Richards. I'm gonna give you a slight intro on our final year project. Along with my team, Renalco Harris, Shaka Walters, Ren Ward, and Dana Scott. So we had a lot of ideas about our press. We were going to build a bigger one, but then like the other group, we didn't have those finances, so we had to go a lot smaller. We've chose the press though because it's very practical in engineering, especially with bearings and as the main use of it, bearings and just pressing in general, mechanical pressing in general. Purpose of the press, we use hydraulic force really to maneuver certain parts and also along with pressing out bearings, could press in bearings as well. We chose the press because it uses all the applications we were taught over the 3 years in workshop by Ms. Thornhill herself. Milling machine, drilling machine, lathe, and so on. Right, so this design was based, we took it from from a previous mini press, but we made modifications where we welded the bottom instead of using bolts like what the other design had, because the weld to us would have been more secure. Bolts would warp and have a lot of wear and tear on them. The welding to us would hold a lot better. Later pass on to Mr. Walters.
All right, good morning.
Gotcha.
Before we go into the fabrication and procedures, I'd like to do a brief description of the materials and parts that were used in the construction. Each part was chosen for its strength, suitability, and availability for the process for the function of the hydraulic press. So firstly, we have the square plate frame, which is 1.5 inch by 1.5 inch. That was mainly for the main frame, which is painted in yellow. Then we have 2, 3, and 4, which are all the L section angle heavies, 2 inch by 2 inch, which are all painted in, as you can see on the prototype, in black. 5 was the flat metal steels, and 6, the 5th flat metal steel is the piece which is viewable at the top, just above the bottle jack. The 6th flat metal steel is the piece usable between the 5th piece and the bottle jack. What's that? 10, the 2 springs. 11, the 3-ton hydraulic jack. 12, the A bolts. 13, 14, 15, 16 Allen key, and 10 Allen key bolts, and 10 hex bolts. And 17, the 1 inch heavy hex nut. Assembly drawings. Here we have a orthographic drawing of the hydraulic press. The front view, the plan view, and the side view. For the sake of continuity, I labeled each part in reference to the parts list. We also have the isometric drawing showing so this one is also labeled, for the sake of space, I only labeled the holes for the key bolts and the hex bolts. Move on. Here we have individual technical drawings for each machine part. We started with one is square frame by 2 for 2 pieces. The upper support L frame with the front and side view, as well as dimensions for the holes. The lower support L frame, which is the L frame just above the bottom, the base, the L base frame. The square plate, number 5, which I said was the black plates just above the three-ton jack. The border jack stabilizer. This was used in intention to stop the hydraulic, the three-ton jack from shifting when it was in use. The border jack support. Well, this is the beam, the black beam that the three-ton jack is supporting on. The base for the border jack to rest on, and the ram that is going to be used for pressing, the actual pressing operation. Yeah. Tools, equipment, and machinery that are used during the development were the heavy-duty equipment were the horizontal bandshaws, the mill machine, the center lace, the angle grinder, and the drill press. The welding plants were the arc welding and glass welding. And the handheld tools were the measuring tape, caliper, center punches, scribers, the thread tack, foil, wire brush, G-clamps, spirit tool, and spirit levels. Then I'll hand over to my colleague, Mr. Harris, for the fabrication and procedures.
I'll attempt to explain the fabrication process and the challenges we had in making this project. Let me first state the most challenging part of this project was not the cutting the material to length or even securing the material. Is the alignment and symmetry. You got to work with an AH frame so everything lines back up perfectly. That was the most difficult part. As you see here, we got the various pieces that we assembled individually first. The channel, the angle, as you can see here. That would be these two parts here, the side frame. First thing we did, we had to tack these pieces to just make sure we got the right alignment before we drilled. This piece is the base where you will have the pressing that actually take place, which is this area here. We have the springs and the bolts. One of the challenges we faced when we was first assembling, we had hexagonal nuts and hex head bolts, but they were too big, which would be this area here. So we had to replace them with Alaki bolts in order to get it to work. The next challenge we also had was with the springs. The original springs that we had were too long, despite the poundage for the springs was correct. So we reduced the length of the springs and increased the poundage. This part here will be the runner for the AH frame and the nut to secure the ram, which would be this area here. This part is the actual stabilizing plate to stop the jack from sliding and we got to apply any hydraulic force. This area here. You can see we got the finished assembly here. Now the process of this, before we put everything together, we had to take each individual piece. So before you could come and measure this part, you had to measure one side, line it up, assemble it first, tack it, then test it, then to disassemble it again and repeat our process at least 3 to 4 times to make sure you got everything in proper alignment. And this is the finished product, where you have the base plate for the hydraulic jack, stabilizing plate. You will have the area for the springs, Allen keys, the runners, base plate, and the legs, and everything come together fairly nicely. At this moment, I will turn over to Donna Scott so he can do an actual demonstration of the product. Next, go.
Yes, good morning. Dana Scott will be giving a demonstration on displacing the shaft from the bearing. course of this project, we face challenges such as initially for the RAM, which is number 9. The plan was to use another molded steel flat piece on top internal trace for the RAM to screw into. But unfortunately, the tool for that was not available. So we purchased the 1-inch by 8-inch stride hex nut. I welded it to the base of the ready bottle jar results. Several adjustments were made along the way to improve the final outcome. For example, to use M10 Allen key bolts instead of M10 hex bolts. In the upper support L frame due to space constraints when fastening. Also choosing to weld the base L frame to the 1/8 square plate frame and 7 the bottle jack support, so some members of the group can gain experience welding, and it was faster than aligning and drilling. This project was essential because it allowed the group to apply all methods of the fabrication process we learned over the 3 years as mechanical engineering students. Be it designing, welding, machining, and adaptability. The estimated time taken to complete this project was approximately 48 to 60 hours, including planning, development, and final presentation. Despite the challenges, the project was a valuable learning experience that highlighted the importance of adaptability, planning, and innovation.